Hello everyone, so today we have a question. Why do spectacles have power while sunglasses do not? The answer is, in sunglasses, radii of curvature of both surfaces are equal in magnitude and in the same direction. Now let us understand this in more detail. Before understanding this in more detail, we need to have an idea about the lens maker's formula, which says that the power of a lens is n2 by n1 minus 1 into 1 by r1 minus r2. Here n2 is the refractive index of the lens, n1 is the refractive index of the medium in which the lens is kept, r1 and r2 are the radii of curvature of both the surfaces of the lens. Okay, so this was lens maker's formula. Now let us see why in sunglasses we do not have power. Now for that we need to draw a diagram. So we'll draw a diagram first. So in sunglass the lens looks like something like this. Okay, I'm drawing a rough diagram. Okay, this is the lens. Okay, this one PQ is the lens. Okay, and this is the first surface of the lens, this is the second surface of the lens. Okay, you are just extending back the surfaces so that we can understand that what was the radius of the sphere from which the lens was cut. Okay, so the sphere from which the lens was cut looked something like this. Okay, now I told that this is the first surface, so this is the sphere from which this part of the lens has been cut, so its radius we can term as r1, and this part of the lens, that is the second surface of the lens, it has a radius of r2 and it is cut from the larger sphere, not larger actually, both the spheres are equal in radius. So this the second sphere that we can see, the second surface of the lens is cut from that. Okay, you can visualize, I hope. This is a radius of r2. Now what is done in sunglass, this r1 and r2 is equal. I think from the diagram it's visible that r1 and r2 is coming equal. Okay, and it's in the same direction. So what will happen, if it is in the same direction, then sign that will be assigned to the value of r1 and r2 will be same, right? If they had been in different directions, for example in this kind of lens, r1 on one side, r1 on this side and r2 on this side, then what would happen? Then one would have been positive, one would have been negative. Then even if their magnitudes are equal, 1 by r1 minus 1 by r2 won't give you 0. But in this case what happens is that r1 and r2 becomes equal. r1 and r2 becomes equal means it's taken to be equal, and what is taken, they are taken in the same direction. So what is the power? 1 by r1, let's say that r1 is equal to r and r2 also is equals to r, so 1 by r minus 1 by r, this will give you 0, and hence the entire power will give you 0. And as the entire power is 0, so in sunglasses we do not have power. But in the case of spectacles, what happens is that now there are various kind of spectacles. Some have a convex lens, some have a concave lens. Let us take the example of convex lens only. So suppose the lens is convex. What happens is that in most of the cases, radii of curvature are in two different directions. They may be equal, they may not be equal, but they are two in different directions. So 1 by r1 and 1 by r2 do not cancel out each other. Okay, so this was today's video.